Good evening, people of the internet. Just picked up a Sega Master system for a really good deal on eBay. The owner says that it won't turn on. Didn't send it with any cables or controllers, but luckily I have a official Sega adapter, so let's try it out and see what happens. Alright, here we've got the Master system. Shanghai inside. Connected to the little TV here. No green LED and no picture. So sure enough, we have no power. So let's open it up. See what's wrong. That's not bad. Alright. So the unit appears to be in pretty good cosmetic shape, so I lucked out there. On the bottom, you got 6 screws. Now, the typical culprit for no power in one of these old power-based systems is the 5-volt regulator chip they got inside. A lot of times people will lose or break their original adapters, so, you know, what other systems does everybody have? Nintendo. Grab that power adapter, plug it in, but the original Nintendo power adapter actually outputs AC. And that'll mess up the Master systems, as they're sensitive to that. Alright, now we got all screws out. Just go ahead and take the top off. Normally sticks a little around the power button. Okay. Alright, we got some screws around the perimeter on this grounding shield they have here. Another problem you find on older systems is corrosion around the solder joints or cold solder joints. Where the adapters plug in. There's a lot of motion that happens over there. Playing a game for a long time, the adapter heats up and wiggle it around. That's a common problem you'll see too. So we'll see if we're lucky. It's as simple as resoldering a couple of pads. Or if we have to replace some chips. Or regulators in this case. I want to make note here that all these screws are the same size that hold the case together and the shielding, except for these two small little guys, and they're part of a heat shield bracket, if you can see that here. And then there's another machine screw instead of coarse thread screw that bolts this heatsink to the top of the grounding shield. Okay. So it looks like we've still got another 6 screws here. We got 2 screws around the card slot reader, 2 screws around the cartridge, and then 2 screws around the power switch. Again, most of these screws are a universal size. The only difference is, and I'm sure it's just for aesthetic reasons, that the 2 screws around the cartridge slot are actually black. Alright, now before you go handling any of the boards, you really should touch something grounded or wear a static strap. That's just good practice to make sure you're discharged. You don't want to blow anything while you're trying to fix it. Alright, first let's take a look at the pads here on the AC. Alright, so you can see those look pretty good. There we go. Sorry about that. Those look pretty good. They're solid. You don't see any corrosion around them, no breaks. Sometimes they get spongy. We don't see anything like that here. That's excellent. So we know that these pads are good. Another thing is you want to check the legs of the adapter itself, as sometimes those can break, and that looks pretty good too. Alright, so now we've got this heat shield here, or heat sink rather, and then that heat sink is bolted to this chip right here. I don't know if you could see, but all the way down in the back is a little screw that holds the 5-volt voltage converter to the heatsink. Now it can be a pain in the butt, especially because they've got a little kind of green Loctite here. But magnetized screwdriver works pretty well. So just get in here real quick. Now be careful you don't knock any of the capacitors loose or anything while you're doing this. And if you got a fine-handled screwdriver, that'll work best. Oh, we got it. Alright. Alright. So this right here is what I'm suspecting is the problem. Now you'll see here where it says ICO. That should stand for input, common, and output. So at your input you'll have your native source, you got your common, and then if this chip is functioning correctly, once we hit power, we should get 5 volts out of the output. So let's hook it up and try it out. Alright, I'm going to set my meter to a 20 volt or 2 decimal range. Hook myself up to a ground point, and then we'll go to the input lead of the voltage converter. As you should be able to see, we're at 0 volts because we're obviously not connected. Okay, so when I hit this power button, we should get anywhere between, I'd say, 9 and 12 volts. These adapters aren't perfect. They fluctuate a little bit. Alright, take that back. 13.4. Alright, so to the input of this chip, we've got 13.4 volts. Now, this chip is an NEC 7805. And just to confirm that I've got this correct, I pulled up the data sheet for this chip. You got your in, your ground, your out. And the 7805 is indeed 5 volts. So that's what we're going to expect to find out on that lead. Let's turn the power off. Disconnect. Come back to the output. And let's see what voltage we get. 0 volts. Let's make sure that's connected. Alright. 0 volts. Alright, so what that's telling me is more than likely this chip has been blown. And if we replace this, we may get lucky and have this power on for, I don't know, 50 cents, whatever the cost of the part's going to be. Alright, let's disconnect power. Take a look in the junk drawer and see what we can find. Let's see. Oh, chips. Let's see here. What is that? That is a Motorola manufactured 7805. How'd you fancy that? Alright. So at this point, in order to remove this chip and install the new one, you're going to want a soldering iron. I recommend a good 80-20 solder. The lead-free stuff is a pain in the butt to work with. Pair of cutters. Alright, let's swap this chip out and see what we can do. So, there's a few methodologies for removing old components. Some people like using some kind of suction device to pull the solder out. I find that that's kind of a pain in the butt and doesn't always work properly. So what I typically do, like I said, a lot of manufactured parts use lead-free solder, so they don't heat up and flow as easily. So I always dab in just a tiny bit of my 80-20 to help soften it up a bit. Good idea not to breathe in the fumes. And then slowly work the part out. Let's see what we can do here. Once you got the part out, add just a tiny bit more of the 80-20 to the pads, because when you remove the old part, it pulls out a lot of the old solder, and you want to make sure that you have enough for the new part to thread into. Alright, so now I've got the chip that we pulled out and the replacement. We want to make sure, of course, that we're lined up. ICO, in, common, out. No problems, we're good there. Wiggle it back and forth. Just work it through. Alright. Alright. When you've got the piece, the new voltage converter all the way into your board, you can add solder to the leads. Just a little bit to finish them off. Alright, those don't look too bad at all. Let's clip the excess off. Touch those up so they're nice and rounded. Alright. You almost wouldn't even notice the difference. Alright, let's test it out. Let's see what we did. We're going to hook up our ground. We're going to hook up to the positive side of the output. Connect our power, and let's see what we get. 4.98 and a green LED. I think we've just repaired this Sega. Let's try it out, huh? Alright, that should be the bare minimum we need. Let's put a game in and try it out. Take our copy of Shanghai. Alright, let's see what happens. Excellent. Alright guys. Well, to put it together is the reverse of disassemble. I'm sure you DIYers have heard that before. I hope you learned something. Obviously if you're watching this, you're into retro games like I am. Other than reattaching the heatsink, which you need to do to that chip to keep it going, that's really all you have to know about before you put it back together. Have a good night.